paper presentations, starting off with work from Hai Young Yoon. I hope I said that right. On her work FraudCenGCL, enhancing fraud detection via dual view graph contrastive learning with account centrality features.
Hello, my name is Young Yoon, and I work in the Korea Financial Telecommunications and Clearings. Actually, when Korean domestic banks are sending money, every transactions are intermediated by my company, KFTC, because it's running the HOFINET, the wiring networks. So we are acting as similar to the correspondent banks in SWIFT. So today I'd like to introduce the novel model. We named it as the fraud centrality graph contrastive neural network. So it used the account centrality features. Okay, first of all, I'd like to introduce the background and motivation. And second, I'd like to introduce the novel framework. And third, I'll show the experimental results, and the data set comes from the HOFINET that I introduced in the first time. So finally, I will introduce the conclusion and the future work that we are trying to do, because my company also runs the domestic CLS transactions and SWIFT transactions. So SWIFT is learning the anti-money laundering initiatives. And so we are scheduling to co-work with the SWIFT too later. Okay, so here's the background and motivation. Since financial transactions are often managed in the form of chronological structured tabular data, so the temporal information can be utilized. When transforming the tabular data into graph data with account data converted to nodes, because you can see that in the left figure, the customer and the account and transaction, that is the tabular data, but it can be represented as the graph data, because you can imagine that the blue dot is the node, which means the customer, and the H means the transfer from the customer Bob to customer Dave. So we can show that in the spatial information. So here, I'd like to explain the figure, the first in the left one, the interbank transfer graph, because I explained that my company runs the wire network between Korean domestic banks. So the left one is the interbank transfer graph. And we thought that the account centralities may be the key features to enhance the performance. Because the first one, the degree centrality, this one means the accounts with many transactions. So the accounts involved in financial crimes often perform frequent transactions within the same group. So you can recognize that blue dot A. And the second one, B, means the closeness centrality. This one accounts close to all other accounts, because you can see that node B is connected to the left graph and the right graph, which is focused on the node C. So node C means the betweenness centrality. So it means the accounts with many intermediary transactions. So these accounts play a role in coordinating fund transfers between account groups. So you can suspect that it might be used in the fraud detection. Okay, so the embedding refers to transforming the features of real-world data into multi-dimensional embedding space. I think that definitely many of us will be accustomed to this thing. So I will just explain the right figure, the embedding space for fraud detection. So if we adopt the account centrality measures, then initial embedding space is optimized to easily find the fraud detection embedding space. Okay, so the existing graph contrastive learning GCL model without centrality, which means the left graph GRACE model, it struggles to form clear and discriminative representations. So the right one is the GRACE model with degree centrality. So adding the centrality feature improves the compactness and class boundaries. Okay, so here in the class 2, I'd like to introduce the FraudCenGCL framework. So the workflow of FraudCenGCL framework is explained here. So you can see the left one, the tabular data and the graph data. So the augmented features means the account features and centrality features. So it is projected in the graph neural network encoder. So here's the account embeddings. Then it can be used. So loss function in the graph contrastive. So the account embedding space, definitely it is optimized so it can be helpful to enhance the performance to the fraud detection. Okay, so here's the main thing about the experimental results. So the data set that was created in March 2023. So the number of accounts is almost 30,000 and the number of transfers is 141. And the result is the number of suspicious, which means the 0.18%. So this data is pseudonymized and the details of the HOFINET data set is shown in the table 2. So here's a lot of fields, include transaction date and transaction time and amount. Definitely it is important because there might be some limit to the wiring. And the media type, which means that it is used in mobile channel or web channels, and fund type is like if it is used to salary to the employees. And the withdrawal bank code, because in Korea there is a checking bank and the letter of credit bank. It is slightly different in the States. And the withdrawal account number and withdrawal bank code. It is. I'll correct that. It means it's similar to the bank identification code BIC in SWIFT, but instead of 11 digits, it's 3 digits. And the deposit bank code that was I explained and deposit account number. So the right one is a graph contrastive learning models. We adapted 5 models to compare the performance enhancement when applied the FraudCenGCL. So there are 5 different models, and definitely the audience might be accustomed to this thing, but the first one, DGI, means the graph embeddings. The second one, MVGLL, node graph relationships from multiple perspective. Third one is GRACE, similarities, and fourth one is BGLL, self-supervised learning techniques. Fifth one is the barrel twin structure. So, okay, so the experimental results, I represented it as the box plots and adapted 2 metrics. The first one in the left is the F1 score micro, and the right one is the F1 score macro. So there are the bottom line means the 5 different models. And when the diagonal pattern means with the centralities features, and the plain pattern means the without centralities. So you can see that models enhanced with centrality feature exhibit better overall performance in detecting suspicious accounts. Okay, so you might now think about that when we adopt all account centrality measures, then it might be not good when you think about the performance, because definitely there might be a lot of transactions. So we need to think about when we had a lower complexity, then will it still remain the performance? So the right graph means the performance of DGI inductive using different combinations of centrality measures. So you can still see that it doesn't lose a lot of performance. And okay, so here it is the continuation of that. So the performance of the DGI transductive DGI TLS with varying GNN encoder architectures. So you can still see that there is not So any kind of big meaningful differences. Okay, so here's the final thing for the experimental results. It's like a summary. So the graph contrastive loss function is explained in the left one. And in the right one, you can see that it was confirmed that the loss functions used during GCL model training have a minimal impact on financial fraud detection performance. Okay, so here's the conclusion. So we concluded that FraudCenGCL improves fraud detection by integrating account centrality features into contrastive learning. And the future work is that, as I introduced in the beginning of the speech, we'd like to work with Swift. And we think that federated learning, because as we all know that federated learning, you do not need to send data in each part. Instead, you just need to send models. And Korean banks are very susceptible to share their customers' valuable information with other banks because they might be used in the marketing. So I think they're adopting models instead of federal. Oh, sorry. Okay.
4 minutes per question.
Okay. So it is almost finished. Yeah.
Any questions? I had a question.
Okay.
What kind of centrality measures did you experiment with again? I saw closeness.
Yeah, those three are all used here. Just actually the degree centrality, closeness centrality, betweenness centrality, as you said, the closeness centrality was adopted.
And how come did you explore other measurements like a page rank or no degree?
You mean the no degree? Just a moment. I think we are focused on the degree centrality, so no degree might be exception. Yeah.
Okay.
Yeah.
Great.
So if you have any questions, then KFTC is always welcoming to have future works with a lot of banks and a lot of financial institutions. So thank you for giving an. Oh, okay. He has. Oh. It is slightly different with the conventional distance methodology. We adopted the Mahalanobis distance methodology instead of Euclidean distance. So we explained that to use in vector space. So, okay.
So I want to know if like exactly how do you each data point input data is a transaction. Right?
Yes. Yeah. Correct.
The account.
Correct.
Initiate the transaction and also the account they transacted to.
Yeah.
A bunch of features associated with the account, including the central. That's your input data point.
Okay.
So what is your output data point? The binary saying whether this transaction is a fraud or not when you do that?
Actually, we had a co-work with the Korean police because Korean police is connected to in Korean wiring networks in Korea. And sometimes they used to say that they have some suspected account. Like, for example, if the accountant's owner's name is Kim Jong-un, there might be definitely a chance he might not be the North Korean dictator Kim Jong-un. But anyway, if the name is Kim Jong-un, then Korean police and the banks thinks that it might be suspected. And if we see that there are a lot of wirings, then it is also, secondly, it is also suspected and it is upper the amount limit, then definitely, okay.
So whether it's suspected or not.
Yeah. Pardon?
Whether it is suspicious.
Yeah.
That binary or multiple layers.
It's actually definitely not to say that true or false, because there might be the false positive and false negative. So we just say that to the Korean police that there might be high possibilities that this might be the suspected one. Okay. Thank you.
Right.
So thank you very much. Yeah.
Thank you. All right. Next His presentation is from Akira Takahashi, and he'll be presenting his work on incrementally verifiable signatures, a cryptographic solution against deepfakes for model and data integrity.
Thank you for the introduction and also